Okay, so to go from original, or to find the derivative, the power rule says whatever power was there before comes to the front, multiplies. And then you subtract 1 from the power, and you're done, right? That's how I went from f of x to f prime. How do I go back? So how do I go from this guy to this guy here?
Divide by n plus 1.
Okay, so let's see. So 2x needs to become x squared, right? 2x has to become x squared.
So n in this case is 1 and n plus 1, 2.
So let's see. So what do I do first? What's the first thing?
Divide the 2 by n plus 1. In that case, n would be 1.
So divide by
2.
always? Always divide by 2?
No.
No, not always. Okay, so I want a rule. A rule is something that always works. So it works for this guy here. What you just said works to become those two guys, right? So for this guy to become that guy. Now, will that same rule work for here to here? So you said divide. You are going to divide. Division is part of it. Division is part of it. So let's start with the power. Let's start with the power. What happens to the power? The power gets bigger by 1 every time, right? The power gets bigger by 1 every time. Makes sense, right? If you're finding a derivative, the power is going to go down by 1. If you're finding the antiderivative, it's going to go up by 1, right? All of these guys here, this guy becomes x squared, plus 4 becomes 4x, right? We're gaining a power, okay? So you're going to gain a power. That's the first part. You're right. What's the second part? Divide by the new power. Good. Divide by the new power. Not the old power, the new power. Well, what is the new power going to be? For this guy right here, it's going to be 2, right? 1. It's going to be different every time. So how do I write that in a rule? There you go, n plus 1. That is the power rule for antidifferentiation. You add 1 to the power and divide by the new power. Right? You add 1 to the power and you divide by the new power. So this guy right here, yours is different, but my first one was 2x. So I added a power. Good, it became 2, right? Good. And then over here, I divided. There was a 2 already out in front, right? But I divided by that new power, and they canceled out. Got a little bit of a lag. Don't know why, but they canceled out, right? There was a power here. There was originally a 2 there, and you divided, and you got 1. This guy here, it doesn't have a power. 4 doesn't have a power. So if I add a power here, it's got a power of 1. And then I divide by the new power, it's 4x. How about 3? Where does 3 come from? How did I know there was going to be a 3 here? It's a trick question. I don't know there's going to be a 3. But exactly, and what does C represent? I know that when I go this way, there could have been a constant that disappeared. Because the derivative of a constant is 0, right? And I don't write plus 0. So I don't know what type of constant it is, but I know that there is going to be a constant. Okay, so how do we take care of that? Well, that's what we're going to do today. But this is the big part right here. Here's the thing about integration, which is another word. So integration is the big idea. How do we integrate? By using antiderivatives. Okay, so we're learning the skill before we learn the concept. So the skill of finding an antiderivative. doesn't have all the rules that different derivatives did. Derivatives had power rule, product rule, quotient rule, chain rule, right? Antiderivatives really have two rules. The first one, you guys have just learned, power rule. The second one is something called U substitution. U substitution is their version of chain rule. It's their version of chain rule. Okay, so just like chain rule took us about a week to do, when we get there, U substitution will take that long. It's not that bad. It's just like chain rule. In fact, it's the opposite of chain rule. Okay. Okay. So today, this is all we're going to do. We're just gonna play with the power rule. Okay. All right. So let's go back. Let me go back to the front. Okay. So a little bit of background. Anti-differentiation is the most common method of integrating. There's different ways of integration. Okay. What is integration? We're going to talk about that probably later this week. We'll talk about what integration means, right? Derivatives mean slope of the tangent line at a certain point, right? That's what derivatives mean. Integration means something too, but don't worry about that right now. The main thing you got to learn is antiderivatives is a way of integrating. It's the most common way. Roughly means opposite, right? Which means we do the opposite of finding a derivative, which you guys just did. You guys just came up with that rule, right? So when we're finding the antiderivatives, we always use this symbol here. It kind of looks like a stretched out S, like if I took an S and stretched it out, right? It's an integration symbol. When we see that symbol, we're most likely going to have to do some antiderivatives, okay? That means it's an integration symbol, okay? And then it'll always have a dx at the end. Like you notice, like the examples have dx's at the end. What does that mean? I'll explain that later. I'm not going to talk about it right now because it'll confuse you even more. I just want to focus on finding the antiderivatives today, okay? Okay, so example number 1, 2x. Let's use our new rule. They gave us the derivative. They said the derivative is 2x. What was the original? Well, let's use our new rule. Our new rule said, let me write it up here. Our new rule said if we have something to a power, we're going to take that something and add 1 power, right? And then we're going to divide by the new power, whatever that power was. We're going to divide by it. Okay? So let me highlight that because we're going to be coming back to this a lot. Okay, so 2x. So if I want to find f of x, I'm going to need to find the antiderivative of 2x. The dx is just it's a thing that always goes on there. It means something, but it doesn't. I don't want to explain what it means right now because it'll, like I said, it's not necessary. I'll explain later this week. Okay, so 2x. 2x is what we're trying to find. So 2x becomes, I add 1 to the power. So 2x becomes 2x squared. And then I divide by that new power. Done. So the antiderivative of 2x is x squared. You can always check your answer because what's the derivative of x squared? 2x, right? Okay. Letter B. So I got to find the antiderivative of x. Okay. Well, I add 1 to the power and divide by that new power. So you can write it like that. Most of the time, they'll have it written like this, 1/2 x squared. Instead of divided by 2, they just have 1/2. It's the same thing. Okay. Do letters C and D. Do letters C and D. And E. There should be E down here. There's 2 D's, make the second D an E. Use the same rules. to do this. Oh, I forgot something. I totally forgot something. We found the antiderivative, but just like we did in our example, there could have been a constant out there, right? So we always end with plus c. Plus c. It takes into account that constant, just like we did down here, right? It takes into account that constant here. There could have been a constant, but the derivative of the constant was 0. So I don't know exactly what that constant was, but there could have been one. It could have been 0. Okay? Okay, so x squared. So you get add 1 to the power, divide by the new power. So 1/3 x cubed plus c. How do we do d without using a quotient rule? So 1 over x is the same as x to the negative 1. They're the same thing, right? Same thing down here for this guy down here. It's the same thing. So to use the power rule, you would just change the power to a negative. Okay? So we're going to do the same thing. So I add 1 to the power. When I add 1 to a power, what do I get? X to the 0, right? Which is just 1. And then I divide by 0, by the new power. So really it's 1 over 0. What does that equal to? Undefined. So this is the only time the power rule will not work. Okay? The only time the power rule will not work because you can't divide by 0. So what is the answer? Not undefined. Yeah. Natural log of x. If you remember, the derivative of natural log was 1 over x. It's just going the opposite way. And then we need a plus c. That's the only time the power rule will not work, is when you have something to the negative 1 power. Well, it's just going to be a natural log. It's just a natural log. Okay, that's a special case. And then the last one, this one's got a negative power too, but when I add a power, it's okay, right? Negative 2 divided by negative 2, so you get negative 1/2 x to the negative 2 plus c. You don't want to leave it with a negative exponent. So you say negative 1 2x squared plus c. Move the negative back, move the exponent back down. Okay. Okay, so integration rules here, kind of like we've been talking about. That's exactly what we've been talking about. The first one, derivative or the antiderivative of a. A is a constant. All right, the antiderivative of a. So if you just have a number, the antiderivative is going to be a times x. You're just giving it an x, x to the first power, plus c. Okay. The second one is just the power rule. Instead of x, I've used u, but it's the same thing. Okay. Add 1 to the power, divide by that new power, plus c. x to the negative 1. That's the special case where it doesn't work. But it's natural log, because the derivative of natural log was 1 over x, which is x to the negative 1. So if you have something plus or minus something and you're trying to find the antiderivative, do each of them separately. So you find f of x dx plus or minus g of x dx. Do them separately. They each get their own dx. The dx has no bearing on the answer. You don't do anything with the dx. It's just there because it's part of the antiderivative. So what if you need to find antiderivative of something, but there's a coefficient already out in front? Nothing. You just use the power rule again. You just use the power rule. A times and then you would just do your normal power rule. You just move the a to the front. So like if you're finding the antiderivative of 5x, just move the 5 to the front. Done. Okay. Or you can leave it in there too, it doesn't matter. The antiderivative of a derivative. What is the antiderivative of a derivative? The original, yeah. If you find the antiderivative of a derivative, you're doing what we've been doing, right? You're just finding that's the original. And then what if you find the derivative of the antiderivative of the original? What would that be? It's just the original. Kind of sounds kind of, why is those in there? Because you will see them later on this chapter. You will see this. You will see this quite a bit. And then when I show it to you, you're gonna be like, what? It's just the original. If you're finding the derivative, right? You find the antiderivative of f, go up a level, and then you find the derivative, go back down a level, back where you started. Okay. All right. Okay. What I want you to do now is I want you to do 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. That's all we'll do today. We'll leave the trig for tomorrow. Okay, so the first 3, just using power rule. Add 1 to the power, divide by the new power. Just don't forget about the plus c. If it's a fraction and you can reduce it, reduce it. If you can't, just leave it 7/2, 7 over 4. It's fine. Number 3, all of the coefficients went away. They all divided evenly, so they just made 1s. Okay, so number 4. Number 4, if number 4 was a derivative problem, we would use chain rule, right? But we haven't learned the chain rule for integration. Is there a different way we can do it using our rules that we've learned so far? Yeah, multiply it out, right? Multiply it out, expand it, using box or using FOIL, whatever method you're most comfortable with. So you get 9x squared minus, what is it, 8x? No. Minus 6x plus 1. Now it just looks like number 3. So the 9x cubed divided by 3 minus 6x squared divided by 2 plus 1x to the first divided by 1 You don't have to write that, but you can if you want. Plus c. So we're going to get 3x cubed minus 3x squared plus x plus c. Okay. And then the last one, if we were doing derivatives, if I gave you this problem last year with a derivative sign instead of an integration symbol, this integration symbol was gone and I gave you a derivative, you would use quotient rule. We don't have a quotient rule. So what can I do before I do antiderivatives? How can I change this so I don't need to do those rules? What can I do to this guy to make it? There's two things I need to do. I'll give you a hint. There's two things. What's the first thing? So yeah, so that the first thing is change the negative, change the on the bottom square root, change it to a power. That's the first thing, right? Okay, so let me change it to a power. So it's x plus 1, 1/2. That's the first step. What's the second step? Can't move it to the top. If I could move it to the top, so I could, you could do that. You could move it to the top. I didn't even think about that, but yeah, you could move it to the top. Just be careful when you do it because it would be negative 1/2 and then you get x plus 1, right? And then you would have to distribute, right? You could do that. The way I was thinking is divide. Both, the top is a binomial, x and plus 1. The bottom is a monomial. So divide each of the binomial terms by that. X and plus 1 are both being divided by plus 1, or x with the 1/2. So this is x to the first power. X to the first power divided by 1/2, you just subtract the powers. So you're going to get x to the positive 1/2 plus, and then this guy is just x to the negative 1/2, which is the same thing you would have gotten if you would have done distributive property. Moved it to the top and did distributive property. Okay, now I can use power rule. Add 1 to the power. If I add 1 to the power, it's still going to be a fraction. It's going to be 3/2 now. And then I got to divide it by the new power. Add 1 to the power. Okay. What's the rule again for dividing by fractions? Instead of dividing by a fraction, you can do what? Yeah, multiply by the reciprocal, right? So instead of dividing by 3/2 and dividing by 1/2 in math, instead of dividing by a fraction, you can multiply by the reciprocal. So really what you're doing here is you're multiplying by 2/3 and multiplying by 2. Okay. All right. That is the power rule. That's probably the most effective thing you're going to use for all of antiderivatives. There are other rules. Like I said, there's one other big rule, and then trig we're going to talk about tomorrow. Trig isn't that bad because you're just doing the opposite, right? The derivative of sine is cosine. So what do you think the derivative of cosine is going to be? Sine, right? So the derivative here will be sine of x plus c, right? All of these guys should look familiar. We'll talk about this tomorrow, but all of these guys right here, they should all look familiar. Okay. All right. All right. We'll finish that tomorrow.